Well, people will come back, but let's start. Okay, hello everyone. Welcome to this post-break session, which is proving to hard to get people back in the room, but they're coming. So as soon as they stop talking about Cloudflare and the UDP stuff, that doesn't work anyways. So who cares? So our next speaker is Maya Sastges from Zipgate. I hope I didn't butcher your last name. If I did, I'm sorry.
That was all right.
And her talk is about separation of platform and product. So how to enable developers to build product features. I think it's very important. It's a hot topic for me as a solutions engineer. So I'm very curious to hear what you have to say. Give it away.
Thank you. Thank you. As you heard from my introduction, my name is Maya Sastges, and my talk today is called Separation of Platform and Product, How We Enable Product Developers to Build Telephony Features. Before I start, let me introduce myself real quick. My name is Maya. I work at Zipgate. As you can probably tell by my accent already, I'm from Germany. So Zipgate is a German company based in Düsseldorf. I work there as a software engineer. Been working there for pretty much 5 years now, and 4 years ago I stumbled into the VoIP telephony backend department on accident actually, but haven't looked back on front-end development ever since. I'll tell you about that later. So let's have a look at the agenda of my talk. I'm going to start by giving you a little background on Zipgate, what Zipgate does as a company, and what kind of platform we are building. Then we're going to have a look at the why, what are the reasons that made us decide to entirely separate our platform from our product logic. I then go over the architecture with you. This is where the talk will get a little bit more technical. And then I'll show you the interface we provide our product developers with. And in the end, I'm going to share some of our main learnings from this process with you, and then we'll hopefully have time for some questions. Let's start with the background then. So Zipgate is a VoIP provider in Germany and also here in the UK. We're mainly focused on B2B products, and our main product is a cloud PBX. We also have some other products. So we do a soft phone that is usable in combination with the Zipgate PBX or with any other VoIP providers really. We also do mobile apps for residential as well as business customers, and we're an MVNO. So we do have quite a few products, and those products each have a lot of features, especially the cloud PBX. And all of these products historically have shared the same platform. Which is, I would say, not a problem per se. It makes a lot of sense to reuse existing infrastructure and existing code for similar things. It can become a problem, though, if the product logic is also, wired up in there. So in our case, it became a big problem, so we decided on a complete platform rewrite with a strict separation there. We still wanted our products to share the core platform, but we wanted the specifics just clearly separated. Which brings me to the why. What are the main reasons we decided on that? To understand the main reasons, we have to have a short look on our old platform. So our old platform was built on top, or is built on top of Asterisk, on Asterisk 11 actually, which is a fairly old version of Asterisk, as most of you may know. And the upgrade just never happened because we used a lot of features, or use a lot of features that really aren't present anymore in newer versions. A lot of that code in the old platform is also very much untested, which is not ideal. And we have a lot of product logic leaking into that platform, which brings a lot of problems with it. One of the problems is, and one of the reasons that made us decide on that platform rewrite, is that the product logic leaking into the platform made a lot of us very unsure about what code was actually executed for all of the products and what code was actually just specific to one product. And that caused problems when developing or maybe when fixing stuff. So developers changed like a little thing about one product and tested that extensively for that one product and finally brought it in production. And then customers called like from a completely different product or from a completely different feature and complained about changes. And that was really hard to pinpoint that this change to another product was responsible for that. So of course you could also say things like that are fixable by or solvable by just structuring your code better, documenting your code better, but nevertheless for us this was a reason to go in that direction. The main reason though was that product developers had to know a whole lot of telco specifics, of telco-specific knowledge to develop telephony features or to fix something about features. Let me give you an example there. When product developers had like a simple feature request, really like putting an announcement for the caller before the call got connected to the callee, they needed to know a whole lot for that. They needed to know like how asterisk works just in general, how a call is built up in there, about the channels, about the bridges, about the playbacks. They needed to know a little bit of dial plan or maybe AGI, whatever interface it is that we were using for that specific feature. Then they needed to know when the announcement could be played. Should it be played before the call was answered or after? Are there any legal requirements for that? So can you really bill the call, the announcement before the actual call, or can you not? So this is just an example, and they were like way more complicated features that they had to develop. And this is like really domain-specific knowledge that you don't really have in developers that you hire from other companies, and also like knowledge that you lose. You know, you lose your knowledge when you don't use it regularly. So it wasn't ideal that product developers had to know all that. And it made the barrier of entry like way higher to develop things for us. We had the same problem actually and the other way around. So because the product developers had so much trouble with building telephony features, the telco experts always had to help out and had to get a lot of product knowledge that they didn't really want or need for their daily business. They rather just focus on like the platform itself. And also debugging got to be a real pain point because tickets got passed like back and forth between product department and the telco team. So that was really not too good. So these were the reasons that led us to the goal that we had in mind, the separation of platform and product, with introducing an internal API for the product developers to use. We wanted the product developers to really focus on building new features without a deep understanding of domain-specific telco things like asterisk, like zip, like legal requirements and telephony. And we also wanted to we as telco experts wanted to be able to just focus on the platform, focus on maintaining it and improving it. So these were our reasons and our goals. Now let's have a look at the architecture. Our platform is built on top of asterisk, so asterisk is our main component. Changing that in our new platform that we are building wasn't really an option for us. There are two reasons for that mainly. The first reason simply being experience. We have a lot of experience in working with asterisk and didn't really wanted that to go to waste unless absolutely necessary. Second reason being we wanted to go for an iterative migration, so we didn't just want to turn off the old platform at one point and turn on the new one, but we wanted to move the features like feature by feature, product by product onto the new platform. And we didn't necessarily want to introduce like more components for that, and with that maybe more hops in the calls as well. So we just went with the asterisk that we already got up and running, and just using the same asterisk actually with different code, like clearly separated code on that being executed. Of course, we do not only have one asterisk, we have multiple asterisks since we have a lot of customers, so we have multiple asterisks that can just be scaled up and down when the customer base grows. Let's refocus on a singular asterisk though for a minute. So for the people that maybe do not have as much experience with asterisk, the asterisk brings its own configuration language with it that is called diaplan, and it also has multiple interfaces which you can use to control the calls on that. There's the AGI, the asterisk gateway interface, the AMI, asterisk manager interface, and the ARI, the asterisk rest interface. And when an incoming call hits the asterisk, it first goes to diaplan by default, and from there on you can make use of the different interfaces. What we wanted was to have as little diaplan as possible, because diaplan is basically untestable, like except for system test, of course, and you should write system tests as well. But getting a good coverage with system tests really is a lot of work, so we wanted to be able to do unit tests as well. So we decided on the call, coming into Diaplan, doing like very basic functionality there, just reading out zip headers, putting them into variables to be able to access them later on, and then just send the call straight over the asterisk REST interface and do the further controlling just over the interface. The asterisk REST interface gives you access to the raw primitive objects of asterisks, so channels, bridges, playbacks, recordings, and so on. And you are informed of these changes via a WebSocket event, and you can also manipulate these resources via the REST route. Yes. So what you could just do to control a call via ARI is just write a service directly connecting to that and then controlling the call with that. But there are problems that come with that, especially in a bigger system. The first being a restart safety. So of course you cannot restart the asterisk while calls are running on that, which is fine really because we don't need to be changing the configuration of asterisk quite frequently. The controlling service though, that is something we want to be able to like develop and deploy daily or multiple times a day really. So we wanted that to be just restartable at any time. And we also have call scenarios with multiple incoming calls that are coming into different asterisks. So, for example, a conference call. And for that, you need to have the shared knowledge in the controlling services, so you will be able to transfer the call to the other asterisk. This is why we introduced another component, which is called the ARI proxy. The ARI proxy is basically ARI to Kafka translator. So it takes the ARI event and then adds a key and publishes that to Kafka and also gets the commands via Kafka and does the REST request and sends back the response. It always uses the same keys for messages belonging to the same call, so the controlling services on the other side will be able to group them together. The ARI proxy actually is an open source project that we are maintaining, so if you'd like to play around with that, there's the ARI proxy, and there's also like an example project which you can use to play around with that. So I can give you the link later if you're interested, so you don't have to take a photo right now. Yeah, and we also don't only have one controller because of restart safety, as I said, but we have multiple controllers with a shared database, which just keeps the call state so the controllers can really be restarted anytime. They can crash without causing any problem to the ongoing calls. Just to be clear, if that picture isn't clear enough, we do have a one-to-one relationship on the asterisk and the ARI proxy, so that actually runs as a sidecar on the same server. The controller, though, is completely independent on another server and also not a one-to-one relationship. So one controller is actually responsible for like multiple calls from different asterisks. They just get messages from a specific key, from a specific key range, really, and this ensures that every message belonging to the same call ends up on the same controller. So let's go back to the simplified pic with only one of each. Little recap here, we have our asterisk, we have our ARI proxy, and we have our controlling service communicating with them via Kafka. But this talk, as you might remember, is called Separation of Platform and Product, and we have also seen awfully little of the separation part so far. So this is just the platform part, actually. What we did is we added an additional layer of abstraction, essentially, behind this controlling service. So what we do is, in this controller, we map all the ARI specifics that we get to an API, really, that we came up with ourselves, which features like more easier to understand concepts for product developers to like use to control the calls. So this is what happens. We have the ARI event coming through ARI proxy to the controller. This does all the mapping and then publishes another event to the product service. We also offer a REST API, of course, for the product service to really control the call elements. And we do this in a separate service as well. Again, to ensure restart safety of the controller, but also because this way we can ensure that the controller gets all the messages belonging together to one call, because we actually use the same keys for the messages on both sides, so they get the controller just gets them by default, all of the messages belonging to one call. Yeah, what is important about that architecture again is that we have really no product specific decisions or logic left of this API. So all of the decisions really are made right here and are communicated to the controller, and this mostly, like at least for product specific things, does mappings. I'll tell you what I mean with this in just a second. Yeah, this is actually the complete architecture. It is, of course, a little simplified, so we do have some load balancers, we have more redundancy, but I think you'll get the idea from this. And yeah, I'm going to tell you more about the interface we have in a second. First, let me tell you a little about what this architecture does for us. So first and most obvious is, of course, the main reason why we did this. This architecture helps to keep zip and asterisk specifics entirely in the platform. So a product developer using this now does not have to know anything about zip and asterisk. The product developer needs to know how to use our internal API, of course, and they have to know how to get a message from Kafka, and also how to use a REST API, which you can basically do in any language you already know, so you have no binding to any specific programming language there, which is also very nice. Another thing we take care of in the platform is scaling and calls across asterisk instances. Scaling, of course, is only half true because they do need to make sure that their product-specific service has decent capacity, but all of the telephony scaling for the asterisks, we take care of that entirely. Calls across asterisk instances, I mentioned that earlier. The products never have to know anything about that because they also don't know anything about the asterisks, really. So they can just basically connect any call to any other call, and we take care of how that works technically. Another very good thing about this is that product unrelated things can be kept entirely separated from the things that product developers have to take care of. So emergency calls is one thing. These cannot be controlled via the API at all. So we just stop them before and just take care of that, because we just don't want to put this burden on someone just playing around with a new feature, with a new product. They shouldn't be responsible for emergency calls to work, really. Another very interesting thing about that is actually availability, or SLAs in my opinion, because emergency calls really should work at least close to 100% of the time. We know we can't really optimize for 100%, but close to 100% of the time, as close as you can get. So we can have very high availability standards for our platform, and the product service can decide for themselves how much availability does that product really need, and they can just don't need to spend that much time on optimizing for very high availability, which I think is a very, very interesting thing about that. Also, things like lawful interception are kept in the platform entirely. They do not need to have to worry about that. Is it called lawful interception everywhere? Is it called RIPER in the UK? I'm not sure. Anyway, it's when the police taps into phone calls of crime suspects. So this is 100% in the platform as well. Which is very practical because you wouldn't want to worry about that as well. These were some things this platform allows us to do. So let's have a look at the interface that we provide our product developers with. Our interface is called ITI, which stands for Internal Telephony Interface. It also has a great visual pun right there, if you ask me. It also works on more than one level, ITI, phone home. Anyway, I think it's very funny. It is a low-level API, actually, because we still wanted to give the product developers maximum freedom to control the call. We do offer some convenience features, though, so like things that are used quite frequently do not have to be re-implemented by the product every single time. Let's have a look at the data model it here offers, which is actually pretty easy. It's mostly just two components, clients and hubs. The client represents a person on the phone, basically. It can be a person on a device or a person that is calling via another carrier, but it does represent a person on the phone. When a new client emerges, you get an event for that, you get a new calling client event, and you do also have commands to invite new clients, so basically to make an outgoing call. And you, of course, get events for state changes, like if a client is ringing, if it is answered, or for things like DTMF, and you can also instruct the API to send a DTMF and stuff like that. The other component is a hub. A hub is basically there to connect other components with each other. So a client only has one connection, and the hubs can have multiple connections, and also the hub is there for anything audio related except for speech, like playbacks and recordings and so on. Now let's have a look at an example that you can build with these building blocks. The easiest example, actually, just a standard outgoing call. So there's this person picking up a phone at home and dialing. So the product service is getting an event with the information that a client is calling. That event has some information in it already about the caller, of course, like what is the number of the caller, and also the target number, of course, because you would need to know where the call goes, but also an ID for a client and for a hub that we just give you by default when someone is calling, because you will need a hub to connect that person to another person. So then the product service needs to make a decision what to do. And in this case, where we are just doing a standard call, the product service decides to invite a new client. This command, again, contains some information about who the called client is, what kind of caller number should be shown to this person. And when this was successful, you get another event with the client that is being invited with the ID and a hub again. At this point, those two are not related at all. There's this person on the phone where the phone is like, that person's actually not yet on the phone, the phone is just ringing, and there's this person on the phone hearing the ring back. Yeah, at this point they're not connected yet, because you might want to build another product where the persons aren't connected just yet. So you need to do another command that instructs those two to be connected. And if that was successful, then you have like the full data model for the standard simple call. And yeah, then you just need to wait until this person picks up the phone, answer the other one, and then they can talk. Of course, this is like the most basic case of them all. So this is something we implemented in a convenience route as well. So you only would need to make one command to build that whole thing up, because that is probably used in a lot of products. Yeah, that was the simple call. I'm going to show you two more scenarios real quick. For example, another scenario you could build with this API is just a voicemail. So there's a client calling, you answer that client, then start a playback and get informed about the playback being started and then being finished. And then you start the recording and again get an event for that being started. And then it kind of depends if the person hangs up or if the recording ended earlier. But yeah, you get events for that too, of course. Another possible scenario would be a conference call. I'm going to omit all the events that you would get for this scenario. But as you can see, there's an additional hub in the middle right here to make sure you can people can hang up or other people can join to build this scenario without having to reconnect hubs, really. Yeah, yeah, so these were basically just this was the interface basically, just a short look of it. Let's have a look at our main learnings from this process. So our first learning was to get feedback as early as possible and as often as possible, because we are building this API to make sure it gets easier for product developers to build these features. And if that doesn't work, like if it isn't easier for them, why would we build it? So we learn to get feedback early, we learn to get feedback soon, to make sure that this was what they had in mind when we decided we would build this interface. Also, it is way easier when you build something for internal use to get to the people you want to get the feedback of, so they are paid to be there basically, so you can just ask them. Another learning we had was deliberate naming, so we thought a lot about how we would name things on the API, for the people using it, of course, but also mainly for us, because we had to deal with the complexity of the ARI, and in addition, the complexity of the API we were building ourselves. So you get kind of, maybe you would try in the beginning to name similar concepts with the same name, but this usually just led to a whole lot of confusion. So we try to choose like distinct names for the concepts on the API. And last but not least, and also pretty obvious probably, is documentation. I mean, as a developer, I've complained about missing documentation more times than I can count. I've also haven't written decent enough documentation just as often probably. With this project, though, we wanted to make sure that the documentation was on point. So we just went for a documentation first approach actually. So we started documenting things before implementing those, which basically ensured that you wouldn't forget it in the end, and then in the end you could just check, oh, did I implement it that way? And it often did us good, this approach, yeah. Also a great motivation for me to write good documentation for an internal API is that the people potentially not understanding something and having questions, like they know where your desk is at, and they also know your Slack handle. So if you don't want them to annoy you, you should better just start by writing decent documentation. So that is it. I hope you got an idea of how we did it. Yeah, I'd be happy to answer any questions now, or other than that, I'll be around for the end of the conference. Thank you.
Just a question about a design decision. I saw your controller API is exposing both reading and writing to Kafka for events. But for the product API, you decided to add an extra box, so you're still reading from Kafka, but instead of writing to Kafka and being symmetrical, you're adding this extra hop and sending REST instead. Why did you decide to add that extra node in the picture? Yeah, we decided that using a REST API is way more common in product developers' knowledge. So consuming from Kafka was something that was kind of unavoidable because you had to get events without doing a command first. So we just decided it would be easier for product developers to use, and we also got good feedback on that. So that was the decision there.
I have another question. How does, when you get a call into the platform, how does the product know that the call is for the product?
Oh yeah, so I omitted that part actually because that would have added a lot more complexity. You have to basically before register the numbers or the extensions to products, and we actually have a step in the asterisk, not Diaplan, but fast AGI, before going into that whole platform thing where we do the request to find out to which product that is. And then we publish them to separate Kafka topics. So you as a product only get the events relevant for you.
Well, thank you. Oh, good.
So question around processes, because I think that you divided platform and product, so that you have some dependence, but also some kind of independence in making decision making, right? So how did that influence your agile methodology? I just glanced at your book, by the way, which is really good. But
Yeah.
how did that change your processes? And secondly, how did it change your organization?
Yeah, so right now we're basically in the beginning phase of that. So we have our first product up and running on this new platform. So at the moment we're working pretty closely connected to the product team right now. It is not the plan to keep doing that, because at some point we will have a decent amount of features on the API that the product developers can just use quite independently. So I think in the long run, or in the medium to long run, this will make us way more independent and therefore more agile, I guess you could say, because you have less dependencies on other teams. Right now, though, we do work quite closely connected to another team.
What about the company structure? Do you also structure your teams now around product?
No, they were structured like that before. This is why it was kind of annoying to debug things in that area, yeah.
Well, thank you. It was very interesting to meet you.
All right, thank you so
Someone
much.
sitting between solutions, product, and engineering. I'll take some pointers. So, thank you very much. And
Thank you.
let's see, we still have a little bit of time, so we'll just give it a couple minutes before we start with our next speaker.